Morning. Alrighty. Morning, everybody. Today we're going to do inverse functions. Okay. All right. So given these two functions, find f of g of -1. Give you 3 minutes, and then we'll start inverse functions. Or we'll go over it, then start inverse functions. Yay. Okay, looks like we're doing okay. Could be better, but okay. So let's walk through how to do this problem. All right. So if I want to find f of g of -1, that is the same thing as f of g of -1. Okay? So this is basically two-step process. First thing I need to do is just like you doing, back in Algebra 1 and before, PEMDAS, right? I follow my order of operations. So I'm going to evaluate inside the parentheses first, which means I'm going to plug -1 into G. So then this becomes f of 2 times -1 plus 5. All right, or instead of x here, I put -1. That is -2 plus 5, or 5 minus 2 is 3. So again, all a composition does is it tells us to take our input, plug it into our first function here, get the answer, take that answer and plug it into our second function here. So if I plug that in, you get 1 over 3 squared minus 4 times 3 plus 3. Which is what? 9 minus 12 is -3 plus 3 is 0. So we get this 1 over 0, which is undefined. Or you could say no solution would be okay too. Undefined is probably the better term, but if you say no solution, that's not wrong. And basically what that means is that this value, -1, is not in the domain of the composition function. That's what that means. That means that this number, -1, is not in the domain because it does not give us an output. Remember, for a function, every input has to give an output, and in fact, every input has to give exactly one output. I'm trying to decide. There is another number that doesn't work. I'm trying to decide if it's worth us finding it or not. Yeah, let's do it. Let's do it. It's never bad to get more examples. All right, so let's see why. So remember, when we're evaluating the domain of this, it's a two-step process. First, we evaluate the domain of G. G is a polynomial. In fact, it's just a linear equation with a slope of 2 and a y-intercept of 5. So its domain is -infinity to infinity, right? There are no restrictions to G of x. Okay, then, and this is the part that always trips people up, is we have to evaluate the domain of f in terms of the output of G. So the domain of f originally is, because it's a rational function where it has values of x in the denominator, this denominator cannot equal 0. So the original domain is that x squared minus 4x plus 3 cannot equal 0, which you can solve by factoring. The left side factors to this, minus x minus 1 and x minus 3, because -1 and -3 multiply to be +3. -1 plus -3 adds to be -4, which means x cannot equal 1 or 3. So you see why -1 is a problem? Is it because it created the output 3? We need to find then the other x value that would create the output 1. So this is what I'm talking about. When we have our domain here, our restrictions of f, we need to look at them in terms of the output of g. So basically, we could say 2x plus 5, that output cannot equal 3. And we could say 2x plus 5, that output cannot equal 1. And then solve both of these. Again, we've already solved the top because -1, right? -5 becomes -2. Divide by 2 is -1. If we solve this one, I don't know what we're going to do once we get to the point where problems take up more than one screen. Like this problem already is really pushing the sloppiness here. But I mean, I've done problems. Okay. Let's go on a tour. You ready to go on a tour? You can go on a tour? Okay, this is the room. Okay. I don't know how to aim a camera. Okay, aiming a camera. Okay, that looks good. So that's the door. Okay, that's the board. Okay, from there to there. I've done problems in honors pre-calculus that take us from there to there. What are we going to do? I guess that long. Like when we do rational root theorem, it can take a long time. It can take a lot of space. It's not necessarily hard. It's more tedious. It just takes up a lot of space to do the problem. We're going to have to erase. And then the problem is, okay, so there's a classic story that I had when I was taking AP Calc in high school. My AP Calc teacher made a mistake, and they were talking about, well, that's nothing. Because when I was in college, they have those moving whiteboards, right? They have the chalk, and then they have like moving ones so that they can get more room. So they'll do the problem, and then they'll move to create more space, and then do the problem, move. So they ended up with like 6 panels of work for one problem. And then at the end, the teacher goes, oh, wait, that's not the correct answer, and went back and reviewed their work. And like in the 4th line, there was a negative error. So he erased 5 panels of work, and they started again. What are we going to do? Like, we could keep doing it, and then if I just erase this and put the end, then at the end, when I get the wrong answer, I can be like, oh, wait, what did we do? Oh, no. Because that's happened to me before, too. And it turned out that it was a negative sign when I was doing one of the rational root theorem problems, and we were on this side of the board, and I was like, what? That's not supposed to be the right answer. This doesn't make sense. And then I go over there, and I check my very second line, and I switch to negative. Okay, anyhow. All right, long story short, there are 2 values right here that are in the domain, -1 and -2. So just, you probably don't need this review, but just as a review, I would write that as the domain of this function is -infinity to -2, stop, union, -2 to -1, stop, union, -1 to infinity. In other words, x cannot equal -1, and x cannot equal -2, because if I plug those in, it'll give me the answers 1 and 3, and if I plug those in, it'll give me 0 in the denominator, which is bad.
How does the 3 turn into a 1 at the top, where it's 2x plus 5 does not equal 3, and then you go down and then it doesn't equal 1?
Oh, those are 2 separate equations.
Okay.
Yeah, good question. 2 separate ones. So those are the 2 equations I wrote from this. Our output here cannot equal 3, and our output here can I equal 1. I just didn't solve the top one because we did it here. We already knew that one. Oh gosh, what's our new schedule going to be? A mess, I think is what they call it. Just awful, I think is another name I've heard for it. So how it works is, to my understanding, maybe I could just pull it up. Okay, hold on. Hold on. Actually, I can do this from another screen. I was like, I can't show you private emails. I don't think we're going to get through our lesson today, the whole of it. We'll get through some of it. Oh, hold on. Before I do that, can I clear this? Does anybody else need to write some messy notes? A little bit of time? All right, it's short, and then I'll show you it detailed. How it works is everyone is becoming an A or B group, hybrid or not. Yeah, the homework is probably not going to be due to. Well, I'm just speculating. Maybe we will get through it, but I'm just speculating we won't. We will see. We might. Okay. Andrew, hopefully that was a thumbs up that you're done and not a thumbs up about what I was about homework. Okay, good. I was like, wait, maybe it was thumbs upping something else. Oh no, did I just take all the notes away? I mean, okay, so technically, I know, okay. A good question. Technically, I have in all of the, oh, maybe I should change this in WebAssign. We'll see. We'll come back and revisit homework at the end of class. Okay, anywho, here's the idea. Every single person is now going to be assigned A or B, whether or not you're remote or not. If you're remote, you still stay remote, but you will be in a group A or B, okay? A students who have opted into in-person classes on Monday will go to their odd classes from 7:55 till 11:20. Or I guess if you take lunch off campus, really till 10:50. Okay, and you have 40 minutes per class. All right. B students will do the same thing. Oh, and if you're a remote A student, you'll zoom in during these times. Okay. If you're a B person that has opted for in-person, you will go to school at 11:35 if you want lunch, or I guess 12:05 is when your first class starts till 3 o'clock. Oh, till 3 o'clock? Oh yeah, till 3 o'clock, okay. There's another one that's till 3:15, that's Wednesdays. Okay, and you get 40 minutes per class. Okay, you do that for Mondays and Thursdays. Tuesdays and Fridays, similar times. If you're an A student, you will go, but you'll go to your even classes instead. B group will go to their even classes. So basically, if you're an A student, your school looks like you get to school at 7:55 and then you leave at 10:50 or 11:20. You leave after lunch. Mondays and Thursdays, you'll be doing your odd classes. Tuesday, Friday, even classes. Okay? If you're a B student, you'll always be doing, 11:35 to 3 or 12:05 to 3. Again, Mondays and Thursdays, odd classes, Tuesday, Friday, even classes. Similar to how we do, odd, even now. Okay? There are two catches. First catch is if you want between 11:20 and 11:35, this 15-minute dead zone and possibly overlapping some of your lunch if you want even more, you can get small group tutoring help. So like if you wanted to come to my classroom after you eat lunch, you could to get some help from me. Or if you're in B group, you could get to school early and stay until you need to take lunch and get some help. Supposedly club meetings will happen then too. I don't know what that's going to look like. Okay, that's the in-person. And then you'll notice that since you're only going to school half, you might ask, what am I doing during the other half when I'm not in person or when I'm not Zooming in. Then you have 50 minutes that each class is supposed to give you to work on your own whenever it's most convenient for you. Okay? So really, these are all 90, but 50 of the minutes are going to happen on your own time that day whenever you can. Wednesdays is still all remote. The only change is there's no seminar anymore, and so classes have been extended a little bit. But so the times are a little different. I think you got 2 extra minutes about in each class, a little bit more in third hour. But yeah, that's kind of interesting. They just changed it so everyone has lunch at the same time on Wednesdays. I didn't even notice that. That wasn't even talked about. Okay, and they've opened up flexibility more for this for teachers. So for teachers, right now, we're supposed to be giving, like a lecture that takes, the whole hour where you're here the whole time, generally, right? That's been loosened up to be a lot more, well, if you just want to have them check in, give whatever instruction you need, and then if they have work time, say, okay, you can leave the Zoom. That is now open, but we'll see. For my class, I imagine most of the time for us, we will continue doing a lecture style like we do now. Otherwise, we're not going to get through the content, and then you won't be able to do AP Calc. And this should be in an email, I think, to you too. I think. Okay. So no, if you are in group A, you are done with Zooming and in-person classes at 10:50. The rest of the time is yours to do whatever for whatever assignments you need or whatever work you've been given. Exactly. You're giving a half day of school every day, remote or not. That might be in person or it might be you Zooming into a class. But if you're in A, you're doing it for the first half of the morning. If you're in B, you do it for the second half. That's the idea. We'll see. So basically, where you're getting 90 minutes of direct instruction from me now, you'll get 80. Or, well, yeah. Is that correct? Did I just do the math right? Because you get 90 minutes from me Monday, and Thursday. But instead, you'll get 40. So it's going to require a lot more self-discipline, is what I feel like. The lectures that I've been able to spread out for 90, I'm now going to have to shorten and give you 40 minutes of it and then say, here's 50 minutes that you have to do on your own. And if you are somebody who's like, once you tell me to do something on my own, that means I don't do it or I do it super late, it's going to make this class harder. So if you're T-Calc, you will be an A group person. And then you'll do T-Calc in the PM. Yeah. Yeah, that's if you're T-Calc, you will you'll be in person or remote, whatever you chose. And it's in, well, okay. If you are remote only now, they may not have a code for you yet. They will give you one. It'll be in your Tyler. If you're not remote only, then you already have a code.
When is this schedule going to happen?
Monday.
This coming Monday?
This coming Monday.
Okay.
I know. It give you a lot of time to prepare and make any adjustments that you need. Not. You will be moved to A group, TJ. Yeah, they're going to go through and switch anybody that has T-Calc to an A group. I don't think they've made that change yet. Yep. Yes, they will. Ooh, will they? Yes, they will. Yes. Ooh, will they? Oh, no. I think they do. Because, okay, my understanding is the Zoom times and all that stuff I put in actually do not matter at all. That's just for, like, creating these nice calendars, invites that I can send out to somebody and it'll, like, add it to their Google Calendar or whatever. But the Zoom link works 24/7. If you click on my Zoom link at any time, you will get put into this channel with the password. You'll be put into a waiting room, and I can join it at any time. So yes, the Zoom link should still work. That's my understanding. If they tell me something else, I'll put it in Google Classroom. All right. All right. I'm sure you'll hear more about that in seminar tomorrow too. But that's the gist. Here's what we got to do today. It's inverse functions. I think actually this is one that goes okay. I think this goes about the same as composite. Maybe a little easier. I mean, you'll tell me at the end of this. We're going to verify the two functions are inverses of each other. That's the math looks weird on that, but it's really straightforward. Ish. Using graphs, that one's easy. I don't even know if I did it. I did, but we might skip over this depending on how you all feel. Determining whether something's one-to-one, easy peasy. These are super easy. Easy peasy lemon squeezy. This is a little bit more of a struggle, finding the inverse functions. After you've done about 3 or 4 of them on your own, you'll be fine with this. A will always be a little bit tricky. Again, it's not because it's hard. It's just like, I'll show you. The math that you have to do, it's just like, it's not math that you've ever really done before. It's not necessarily hard. It's just, I don't know, it just feels strange to people. So if we were trying to find inverse functions, here's our informal, actually, is this, this is the first sentence, is the first 2 sentences is the informal. The last is actually the formal definition. That's the formal definition. So the idea here is if I have a function that sends things from a set A to a set B, this is my function f. All right, then f inverse does the opposite. It takes things from B and sends them back to A. So for example, and we denote that, okay, this is another thing that messes us up. A lot of people think that this is f to the -1 power. It is not. It is f inverse. This is not a -1 power. This is not an exponent. It is a superscript that denotes inverse. Now I know you say, Mr. Lake, that does look like it's in a superscript and it's a -1, just like I would do anything to the -1 power. And I have to tell you, you are right. They look exactly the same, but they aren't the same. Just like the word, you know, I should have had a good analogy for this. What's a word that you could say that can mean 2 different things depending on its context, but still spells the same?
Air.
Air. I should have done any. I should have had an example. Let's see. I could do a silly example. March. There we go. April. Here we go. April got new shoes. Our last month. I shouldn't have chose April. I should have chose something else, but is April. Or was. Who says is? Get out of town. Was. Right? And here, April and April, those look exactly the same, right? The same word, but they mean different things. April got new shoes. This is April. This is a person whose name is April, right? Last month was April. This is referring to the month of April. So this notation looks exactly like raised to the -1 power. It is not. It looks exactly the same, but not. It's not. This notation here means inverse. I will have somebody on the test, when I ask to find that, they're going to take this function and raise it to the -1 power and then tell me what that is, and they will get 0 points because that's not what that is. Okay, so F inverse takes things from B and sends them back to their input. So in other words, and this is the formal definition, if I do a composite, F of F inverse of X should give me X. And F inverse of F of X should give me X. If I take X and plug it into F to get some output, and then my inverse takes that output and just sends it right back, I should start with the exact same thing, right? My start and my endpoint are the exact same things. Anything F inverse does, F should undo. Anything F does, F inverse should undo. That's the idea. So for example, if F of X is X plus 6, that takes, if I plug in 0 as my input, I would get the output 6. Its inverse function would be X minus 6, where if you gave me the input 6, 6 minus 6 would give me the output 0. It interchanges the X and the Y values. So my inputs become my outputs become my inputs. But most important thing that you're going to write down on this whole slide is at the bottom, which actually you already wrote again. But this is the key. They might ask you, they'll ask you to do this on the ACT. They'll ask you to do this, you know, on a quiz test, which I guess for us, we won't have a quiz. It'll just be a test next Wednesday. This. If they ask you to verify that two functions are inverses of each other, what you have to do is this math. You have to do a composite. And the weird part is normally when you're doing math, you feel like at the end of all your math, you should have like X equals a number, right? That's how most of your problems work. That's not how this one works. At the end of your math, you should have this composite function equals X. After you're done simplifying and combining like terms and all that kind of stuff, at the end, you should just get the answer 1x, and that's it. I think you probably have noticed, but if you didn't, I graded all the homeworks, everything to this class is up to date, except, or it was up to date yesterday morning. So if you were not doing your homework, you should go do your homework. Okay. And I know some people did it that night or whatever, and I haven't updated it again yet. I'll do that maybe today or tomorrow. It'll be today or tomorrow. I can do that. But yeah, if you haven't done it yet, please do so. If your quiz grade was bad, remember you can correct and or retake it. If you correct it, you can send me your corrections on paper, right? Like number 1, this is what the answer should be. Number 3, this is what the answer should be with work. And then I'll get you a letter grade back. If you want to retake it, let me know. We'll have to schedule that during seminar. All right. Can I clear and move on, or does anybody need more time to write? Okay. Boop. Oop, 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 oop. Sorry. Well, I guess you can, I just won't move on. I didn't really actually annotate anything useful. I put stuff in boxes. Here's a box. circle that. What did I do? Circle that. Set this is inverse. The fact that they use the same notation for inverse and raised to the -1 power is actually very controversial in the math community. There are some people that are like, that notation is the worst notation in all of math. We should not use that. And so some textbooks have moved away from that and used the term arc instead, especially when it comes to trigonometry. When it comes to trigonometry, it's so bad. It's even worse because this notation and this notation are not the same thing. One of these is sine raised to the -1 power, and one of these is the inverse sine, and those are not the same operation, and they look exactly the same. So again, super controversial that they use that notation. It is pretty good, isn't it? What'd you get? Oh my gosh, you got so much. That's a lot. Okay, good. I'm glad you liked it. Okay, well, yeah, well, you can do that. 1 on 1.5. Where did I go? Oh, you can't see that now anymore, can you? 1 on 1. Okay, so the idea here is I'll just plot one of the points for you. If I'm adding these functions together, then I'm just adding it's f of x plus g of x. So for example, if I want to find f of -2, or f, sorry. If I want to find, what, get out of here. If I want to find f plus g of -2, then what I would do is I'd find f of -2 plus g of -2, right? F of -2 is 1. G of -2 is -3. So if I add 1 and -3, I would get my first point is what? -2. Bink. Oh, no, I plotted that at the wrong point. Bink. Here, okay. Okay. And -1, again, I would just, you can go through and work all this, but really all we did there is we added the y values together. And we'll do that here. 1 plus 0 is 1. 0 plus -1 is -1. And so on and so forth. That's all you do. You just add the y values together, and then do you have to connect it? Ding to dink, ding to dink, ding to dink. Oh, do you have to click it every time? That's silly. Whatever, but that's what you do. Okay, moving along now. Here we go, example. All right, for example, if I have 2x cubed minus 1 and g of x is equal to the cube root of x plus 1 over 2, determine if they're inverses of each other, or verify that they are inverses of each other. So we're going to do f of g of x, and we want the answer to be x at the end of this. That's the goal. Okay, so if I take g of x and I plug it into f, instead of writing x here, I'm going to write this. So it'll be 2 times the cube root of x plus 1 over 2 cubed minus 1. All right, and then I simplify this. So again, use your order of operations. If I'm inside the parentheses, the cube root and cubed cancel out to leave me with 2 times x plus 1 over 2 . You see the 2's cancel out. I get x plus 1 minus 1, which is x. Yay! That's all there is to it. You just plug your one function into the other, replacing every x in that function with this mess. And then you're just simplifying. And the simplifying should be easy. It should be like, oh, this cancels out with that. This cancels out with that. 1 minus 1 is 0. That's what it should be. Like once you get it, it's just weird math because most of it is like, okay, this is super easy the whole time. I'm just canceling out stuff. At the end, I have x, which might be weird for you because you're like, at the end of a problem, I should have, like x equals a number. That's the goal, right? But that's not the goal of these problems. We're just determining whether or not they are inverses. Okay, that technically speaking, that is enough to know that these are inverses. The definition, however, remember, goes both ways, right? F of F inverse and F inverse of F. So we should, technically speaking, also do G of F of X and make sure that that works too. So then I'm going to take this and plug it into G. So now I'm going to take this and plug it in to right there. So this will become the cube root of 2x cubed minus 1 plus 1 over 2. Oh, no. Correct, TJ. That's exactly right. Over here, again, you're going to notice that things are starting to cancel. In the numerator here, -1 plus 1 is 0. No. No. Okay. So that becomes the cube root of 2x cubed over 2. 2 divided by 2 is 1. So then this becomes the cube root of x cubed. Again, cube root, x cubed, those cancel out. So it's just x. So again, yay, it worked. I got just x. That's what I wanted to get. So that's it. That's the goal. When you're doing all these operations, it should cancel out on every step so that you're left with x at the end. If that is true, then these are inverses of each other. If that is not true, if this is like 2x or if it's x plus 4, like you had an operation at the end where there was nothing to cancel out with it, and so it just stayed there, then that's a problem. Because remember, G, if it's an inverse, should undo everything that F did. And F, if it's an inverse, should undo everything that G did. So if there's something left over besides just X, then that means that they are not inverses. All right, anybody need more time to write? Or can we clear and move on? A little bit of time there. A little bit of time. Time and a half. Okay, so Mariah, you ask a really good question. What if it's in inverse one way but not the other? Like, what if one of them gives X and the other one doesn't? I'm trying to think. I'm trying to think back to my grad school math classes over this. I think that it is impossible for that to happen. Is it? I think it's yes, I think we proved that it was impossible for that to happen. That's why and for your class, it won't happen. For your class, it won't happen. If this first one works, the second one will work. Yeah, if this first one works, the second one will work. Now, technically speaking, theoretically, if one works but the other doesn't, it wouldn't be inverses. But, so technically speaking, if there was some function, f and g of x, where in one direction it worked, but in the other direction it didn't, then they would not be inverses of each other. However, I think it is impossible for that to happen. I don't know, but there may have been somebody that came up with a way to do it, like a fancy way, and I just don't know about it. Like it could be, like there's always these fun problems that like have no real world application per se, but you know, violate one rule. There's a huge calculus problem like that. There's a big problem in calculus where there's just one function that made it so that the rules of calculus were not working as they were supposed to be, and they had to go back and change those theorems to rule out that one. It's really interesting. It's this function. This one I do know about. This is the function. It's a piecewise function. F of x, the output is 1 if x is a rational number, and 0 when x is not a rational number. And they had to go back and make a whole bunch of open limit arguments or open interval arguments to rule that case out. The graph of this function, I think I may have even talked about this class in this class. The graph of that function looks like this. Looks like this. And it passes the vertical line test. I know you look at that and say that doesn't pass the vertical line test, but at this point, it goes through that line. There are little tiny gaps all over this that are impossible for you to see, and there are little tiny gaps all over this that are impossible to see. If you want some math history stuff, you can look at that. All right, this is what we'll end on. You tell me which of these is the inverse of that. And again, you just need to plug this into that, plug this into that, and see which one gives you the answer X. The homework is going to be due Monday, not tomorrow. And now I have to go change that. 15,000 places. 15,000 places I have to change that at. You know how many places I have to change that at? 15,000. Okay, change to WebAssign, classroom. All right, other than that, that's going to be the end of class. the answer, if you want to write it down, or if you're done yet, you should have gotten that the, where is it? H of x. H of x is the true inverse function. G of x does not work. Alrighty, unless you all have any questions, have a good rest of your day, and I'll see you Monday, or see you tomorrow. Bye.